Hello, this is the mathxl test review for Unit 7, and I have a couple of problems that I want to go over on request of a student. The first couple deal with going on how we, Georgie, on how we determine whether triangles are similar. So there's three different ways. There's this side angle side postulate, which says that all three sides have to be proportional. So if you set up all three of these fractions, you should get the same value. Angle angle says that you need two corresponding angles that are congruent. So for instance, if it were angle angle, let's say that that would be 30. And even if I had a much larger angle, if this were 90 and this were still 30, then I could call it angle angle similarity. And then the third kind is called side angle side. In order to have side angle side, you need a side length, an angle, and a side length. And then in another one, you need the side length to be proportional. So if that's 1, this would be 2. If this is 3, this would have to be 6 so that they all give you the same fraction. And you need the angle, so side, angle, side. All right, so looking at this diagram, I have a feeling that it's going to be side angle side. Yes, and the reason why is because there's really two triangles stacked on top of themselves here. There is this small one up top, which is PSQ. So this side length is 24, this side length is 16. And then there's the larger one, which is RST. And RS has a side length of 36. And ST has a side length of 16 plus 8 is 24. So angle S is congruent to angle S by the reflexive property. They lay on top of each other. And then I'm just going to double check this proportion, even though I know I'm right. It says that PS, well, the length of PS is 24, over RS, the length of RS is 36, equals QS, and I'm just reading the letters that I circled there, 16 over 24. So if I do that in my calculator, 24 divided by 36, 16 divided by 24, they each equaled 2/3, so that means that they are indeed proportional. If we were checking for side angle, or I'm sorry, for side, 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 you'd have a third that would all match, and for angle, angle, you don't need to check any of that. All right, let's get rid of this, and I'll go to the next one. All right, next one that my student requested was problem number 6. This is very similar. This one appears like it's going to be angle, angle because they gave you two angles, but you have to check it. If you, well, first of all, remember the three angles of a triangle add up to 180 degrees. So if I take those two given angles and the one I have circled in green and subtract the 36 and the 24 from 180, I end up with 120. Now I'm going to do it for, I'm going to circle this big one here in blue. If I do 180 minus 36 minus 113, I ended up that this angle is 31. So in regards to angle-angle similarity, these two triangles have one pair of angles congruent, but they lack the second pair because the 120 doesn't match the 113 and the 24 does not match the 31, which is why the answer is D, that it's none. These two are not actually similar. Let's see. Problem number 5. Okay, problem number 7 was the next one requested, and this one took me a couple of tries to really realize kind of what it was asking. So 10-foot post and then a 16-inch shadow. Then we have a 124-foot shadow, and we want to know how tall the tower is. So you have two similar triangles here, but the issue is that this is in inches. So convert 10 feet into inches, and it ends up being 120 inches. Convert 124 feet into inches. There's 12 inches in every foot, so I'm just multiplying that number by 12, and I got 114.88. So I'm going to set a proportion. I'm going to choose to go height of the object over the shadow equals height of the object over the shadow. When I do this cross multiplying, I get a pretty big number. So 16x equals a big number. I'm going to divide all that in my calculator, and I still get a pretty big number. Divided by 16, I ended up with 11,160, but this is inches. The problem is asking for feet. So I'm going to divide this by 12, and it's going to give me my answer. Oops, sorry. And my answer ended up being 930. Your numbers may be different, but the process should still be the same. You've got to get everything to the same unit and then back again. Or choose to get your inch, that 16 inches into feet. I just went the other way with it. Hold on, buddy, I'm almost done. Go ahead. Okay, problem number 9. I know a lot of the students really hate these problems. Redraw them and relabel them. So we have a small triangle, we have a medium triangle, and then we have the great big triangle. The small has a right angle of O. There's a length of N. So my tall side is no, and my short side is MO. For the medium triangle, the right angle is O, the N goes here, George, and the tall is here. And let's see, large is N, this piece goes here, and then that hypotenuse, oopsies, that looks the same, doesn't it? And then the hypotenuse goes from M over to L. So I have it labeled correctly. So what I did was I actually just did process of elimination, and I checked all the options until I found one that worked. So the first one goes L, N, M. L, N, M. Okay, so that's the way they want me traveling around the triangle. So I checked the middle one. L, O, N. Still looks okay. But N, M, O was going the wrong way, so I knew that wasn't it. I tried it again with the second one. L, N, M, same direction. L, O, oops, I'm sorry. The blue one should have gone L, M, N, that way. This one, the center one, is going L, O, M. So they're going in 2 different directions, so it couldn't have been that one. And then when I checked the third one, it ended up working. Let me see if I can grab a different color. Still blue. All right, so check the first one. L, M, N. So I'm going that way. L, N, O. Still going that way. N, M, O. Still going that way. So this one is just assessing your ability to kind of travel in the same order for all of them, but it's easier to do when they're redrawn. Not that my drawings are beautiful, but separating the 3 triangles and relabeling is how you will be most successful with that problem. And then problem number 10 is more of an applied problem of what we just did. So I'm going to start by redrawing the triangles. I have my small, I have my medium, and I have my large. My small one is this one right here. 2x, and then its hypotenuse, which is across from the 90 degree, isn't labeled. The medium triangle has a short side of x, a tall side of 7, and the hypotenuse is always directly across from the 90 is y. And then the tall one, or the great big one, has no length here, but it has that's the tall side of y because it's making the 90 degrees, and the hypotenuse is the 7 and the 2, so the 9. So if I'm going to go ahead and find x, I'm looking at these two triangles, and I'm going to choose to do 2 over x equals x over 7. So I went from the short side to the tall side. Short, tall, short, tall. So when I cross multiply, I got x squared equals 14. Square root both sides. X equals, to simplify square roots, we break down the number into prime factors. 2 doesn't go any lower, 7 doesn't go any lower. We have no pairs, so the square root of 14 just doesn't go any lower. And that was my answer for x. Then if I want to find y, there's a y in the medium and a y in the tall. So I have in the tall, in the largest triangle, I have the tall side and the hypotenuse. So I'm going to make fractions go tall over hypotenuse. And I'm going to use 7 over y equals y over 9. So when I cross multiply, y squared equals 63, square root, y ends up equaling, let's see, I'm going to use 9 and 7, 3 and 3. So what we're looking for are pairs. So I have one pair of 3's that came out, and then this leftover 7 has no pairs, so it stays inside the square root. Let me just give some of these a quick browse to make sure that I'm allowed 15 minutes in every recording, that there's nothing else that stands out to me. Get rid of all of this. All right, so let me go back to problem 1. This should be straight up cross multiplying. Just be careful that when you do, for instance, 3b, 3 minus 4b, that when you're cross multiplying this top value here, that it's 6 times 3b minus 4 equals 2 times b minus 5. Problem number 2, hopefully 2 is straightforward. For problem number 3, we're setting up proportions. These are similar. They would be similar by, if we were talking about the idea of angle, they share this top angle here, and we have an angle there. I think that's the only thing we'd be able to do. So this one here, I'm going to do y, since it's the side length of the short, and then the side length of this tall side is actually 16, so there's no subtraction that's needed. We have y on this side, x on this side, 16 over here, 30 over here, and then the other side, I'm going to use 17 over 34 so that I avoid the x completely, and I'll make a second proportion for the x. I would do x over 30 equals 17 over 34 over 34 again. So that should be able to be cross multiplied. All right, I found problem number 4. Let me go over this one quickly. I have about a minute and a half in my 15-minute video. Why are the triangles similar? I'm looking at the idea of, it's probably going to be angle, and I'm thinking that because they gave me no side lengths, but I know the reflexive property, and I know that these markings mean parallel, so if those are parallel, and I'm going to draw a transversal in here, there's an angle that this one and this one, let's see, where is that? There's got to be alternate interior angles in here somewhere. Here. Alternate interior from here to here. So yeah, that one on top, that one on bottom. So it really is going to be angle. Is that an option? Here it is. Because those angles that they have listed are going to be congruent. And to be angle, well, actually for anything for similar, you need angles to be congruent and you need sides to be proportional, meaning that the ratios end up matching. I hope that helps. Good luck.